Hello guys, and here in this video I'm going to talk a little bit about working with dates to visualize time-based data. Please stick around with me in this video, even if you feel at the very beginning of the video that you know it all and this is quite easy, but please stick around. This is important. And there are going to be some important stuff here. We talked about continuous and discrete fields. Talked about how continuous fields has to do with either dates, prices, speeds. Basically, it has to do with anything that is measurable and on a scale, and it contains values. So there are values in the data field, and they all can fall anywhere on an axis, on a scale. So the word value is very much related to continuous values and axes. All right, so in terms of terminologies and the wording here, continuous, values, and axes, all related, very highly related. With discrete, we're talking about units here. We're talking about categories. We're talking about this discrete components, distinct units. They fall into specific categories, Here's an exercise. Please take a moment and pause this video and answer this question. All right, welcome back. So the question is, this is a chart showing the maximum weight of common dog breeds, and it's just asking you if both of these fields are continuous. Of course, both of them are not continuous. Basically, one of them is categories in here, and another is on values on an axis. One is in green, which is measure, and one is in blue, which is a dimension. So dog breed is continuous. That is not correct because this is in blue. When it's in blue, it is a dimension, and it is also in categories, in terms of categories here. So dog breed is discrete, that's correct, and weight is continuous. Yes, it's continuous because it's in green and it's on an axis. So this is the correct answer. It's kind of questions and easy questions that might come into the specialization certification. Work with date fields in your view. Also very important that we understand that we have continuous values, discrete parts. Yeah, parts is for discrete, values for continuous. And also we show data across time along an axis. This is continuous. When you're showing data across timeline in an axis, continuous. But when you are in the view as a discrete date part, this is when you have month. Basically with date part, we're talking about aggregating data into categories. So these are the little kind of like sentences, concepts that I would like you to pay attention with when you're reading questions in the concentration, because what happens is that you will be faced with so many questions, so it's a time game. So show data across time along an axis, maybe most likely continuous. Aggregate data into categories, that is discrete. Continuous data values, let's take a look at this example of a continuous data values. Not all the time it is in line, not all the time line graphs or line visualizations has to be related to continuous, but most of the time continuous is line. So continuous date values, also called date values, these represent chronological progression of time. So this is also important to know that it's about the progress over time. Chronological, there's a time order here taken care of. It's in green. You add the date value to a view in Tableau so that you can create a continuous timeline along an axis. And this is an example we have here, sum of sales, profits, GDP over years. Please reproduce this on your own. This will take you 1 minute. Pause the video, recreate this on your own. If you don't have a GDP in your super sales, it's all right. We don't have it. It's in another data set. Just use sales or use any other measure like profits. Let's take a look at what do we do with the discrete date parts. With the discrete date parts, so we talked about with the continuous date values. So what we see here, we see how the progression is over time. So we can see here that we can see that it's increasing over time, right? Yeah. So over here, what do we see? With the discrete date parts, distinct, it's basically it's about distinct units of time contained in your data. So this is an example, a very interesting example where you have a sum of sales and you have months as a discrete. So here we have January, February, March. So you can see that this axis here is not even an axis, it's just the categories here. The date is a distinct unit. It's more of a part. Here's January, February, March, April, all the way to December. Okay, then we have sales. And then we have a stacked bar. And we learned in Tableau in class that we get the stacked bar by dropping some data field into the color. What data field you think is it dropped into the color shelf? I'm not having it here, but I want you to reproduce this. So you have here order date as discrete, as you can see in month, and then you have the sum of sales. So what do you think that we dropped here? This is year, obviously, 2017, 18, 19, and 20. I think this is what we dropped into the color is something in year. Is it discrete or continuous? Try it and get to reproduce this. I'm not going to answer this question. It's so obvious for most of us. If it's not obvious to you, then trial and error will guide you through. And you need to study. You need then to go back to the other also slides that has to do with dates and study. Okay? All right, when you add a date part to the view, as in Tableau here, what happens is you create not an axis, you create headers. All right, and order date here is a header. So you create these little headers here and here, date order, for the units of the date part, rather than creating a timeline on an axis. And as you can see, this is an example where the order date has created these headers for certain months. What do we see here? I will explain a little bit about trends in future slides. Over here is a question. Would like you to pause this video, answer it, and come back to me. So as you can see, this chart is built to determine which day of the week had the most sales last year. Which of these options was used to create the view? This is a very important question, guys. Was it the date part of week number? There's no week number, no. A date part of weekday? Is it the day part? Yeah, it's weekday, okay. Let's see the other options. A date value of week number. Is it a week number? No, there's no date value of a week number. A date part of day. What's the difference between a date part of weekday and a date part of day? This is a very important question. A date part of day. How many days do we have in a month? We have 30 to 31 days. So a date part of day is 1 through 30 or 31, depending on, 1 through 31 in fact. I'm sorry, it's 1 through 31. So a date part of day is days from 1 to 31. A date part of weekday, it's days in a week. So this is the right answer, a date part of weekday. Even though usually we say weekend and weekday, you might be a little bit confused by saying there are weekends in here, and weekday in fact is Monday through Friday. So this is wrong. I'm more tempted to choose this one. Please reconsider. A date part of day is rolling from all the way from 1 to 31. A date part of weekday is, as you can see, it also includes the weekend. So don't be confused about it. This is a very interesting question, I thought. Also, I'm going to talk in the coming video about how do we change the order of the dates of the week. Like for example, here, the calendar starts with a Sunday. What if your manager, nobody works on a Sunday, so most of the meetings and the statistics come from Monday. So what do you do and how do you change the calendar here so that it starts from Monday, rather than Sunday? We're going to talk about this in a future video. Configure the continuous date values and discrete date parts. We've done this 100 times in class. Maybe I'm just, exaggerating. We've done it a couple of times in class. But for the sake of not bothering you, I know it's not fair that I just count minutes, that I just finished the class. I'm not going to do this to you. I'm going to let you do it yourself. I mean, you read it and redo it. It's going to take you less than 5 minutes. Just go over this slide and redo it, or reproduce what it's written here. Or is it an activity? But wait a minute, is this one? Oh, this is not an activity. This just say that with date part, it's a header. You're creating headers and read through it. And with continuous range of data of time, this is what you're getting with values along an axis, with date value, which is a continuous date, you're getting values along an axis, which is a continuous range of time. So read through this if you're still not clear about what we've just covered. This is very important. The line chart uses a continuous date value to show change across years. So how about this bar graph? The bar chart uses the discrete date part of month to show totals by individual months. Do you see here we have order date as a header? We don't have a header here. Do you see that? This is what we mean by it creates headers. All right, so when we have bars that show totals by individual months, does this mean that we can compare? It's easier to compare? Yes, it does mean that it's easier to compare. When to use a continuous date value? When? You use a continuous date value to visualize how your data changes over a range of time. Yeah? So over the years, over a range of time. And this is an example over here. So you can see in this example that the GDP or the sales or the profits, whatever this line is you want to consider, this you can see that it actually increasing, it has an increasing trend from year to year, okay, over years. And you can easily, at any point, you can hover over a certain point and see the specific value of the measure. And when do we use this data part here? We use this data part, it's easier for us to compare. And also somehow we can also take a look at the trends. I'm going to talk about this in future slide. For now, I would like you to follow through these slides. Here is the activity. I'm sorry, I thought it's a little bit earlier. So here's an activity, guys. It's really easy activity. I'm not going to go over it. I want you to do it yourself. Why? Because I want to take more time. I have a lot of material here prepped for you. Maybe you've noticed I have about 80 slides that it took me hours to prep. So I don't want to spend the time of the videos for 90 minutes doing the activities, and then I wonder whether you're doing it or not. You're just watching me do it and say, oh, it's easy. But you know what? I want to train you because you will be asked to do certain actions. So I want you to get used to this language, read it, follow through it, guys, and reproduce whatever mentioned here. Over here, you already know, we've covered this in previous slides, that this is the date part over here, this is the date value, but please read it through and reassure your understanding. Here's the action that you need to do. You need to click the month here and see what happens. And I want you to pay close attention to the language, because this is what will be used in the questions, in the certification, and in the quizzes that I will give you. So you can see that when you click on the plus and minus signs next to the date value axis, you will be able to drill up and down in the data, on the date. Now I want you to notice one thing, and I'm not going to mention it in right now in the video. When this data field or this date is continuous in a green capsule, as you can see here, and it has a plus and minus, of course, to drill up and down, right? Does it reproduce other cells, other capsules along the columns? Excuse me, along the columns shelf. So if you drill down in the data, or in the date field, and you click this pluses and minuses and all that, does it reproduces or creates a copy of the level of detail? What does it do? So please have note that and take a note of it. When to use a discrete data or date parts? We use a discrete date part when we want to compare a measure for specific units of time. For the continuous, we talked about when do we use it. You see the change over a range of time. And now we saw how we can change from discrete to continuous, and we saw I would like you to check what happens when you click on the plus and minus sign here, meaning when you drill down into the data type. Now let's go back to the discrete. Now this is a little summary. Now let's go back to discrete. What happens? You can compare a measure for specific units of time, such as months, to each other. And here's a very interesting example. What's interesting here is that, let's read together. For example, you might want to compare sales for every June to sales in every December. So you want to see maybe the peak month in summer is June and the peak month in winter is December, and you want to check the sales over years, but in June, and sales in June versus sales in December, to identify recurring or seasonal trends, all summers, all winters. So if you are thinking mistakenly that only continuous date values are used to identify trends, you're wrong. You can identify trends over a range of time using continuous date values. But if you want to identify recurring or seasonal trends, recurring that happens over the years, every summer, every winter, yeah? So it's recurring or seasonal trends, you definitely use the discrete date part, okay? What happens is Tableau creates headers for the units of that date part, and you can easily use it to compare within the visualization. Let's take a look again. I told you that we're going to go over this one more time. So in this view, as you can see, the discrete date part of month, of order date, you can see that it is sliced into different years because we added the year in discrete into the color. And you can see in certain seasons, there's higher sales, or in certain months of certain seasons. For example, if September, October, November, December are considered winter, then we can see that September, November, December has the highest sales. And in general, seems like winter in general has the highest sales compared to other months. And in here, in other than the winter months, we have May that has a standing out kind of like sales compared to the surrounding months or adjacent months. Yeah. So read through it. It's about seasonality here of higher sales in the winter months. You can spot that, and this is spanning multiple years. You see in the stacked bar. You can see here. Most of these stacked bars, showing that sales are higher, in winter. It's not meaning that this September is not experiencing very high sales because most of the sales have been made in 2020, for example. No, it is very consistent. You see that almost very consistent throughout, and seems like in general, winter experience more sales. All right, so in summary, we use continuous date values to visualize how your data changes over a range of time, such as a year. When we use it, we are creating an axis that shows the chronological progression of date. When we're using discrete date parts, we want to use it to compare a specific unit of time for a date field, such as months, to each other. So it's very interesting for us to use it when we want to check for recurring or seasonality or recurring trends in seasonality. When you're using discrete date parts in general, what you're doing is you're visualizing the aggregation of a measure into certain date parts, and you're creating headers when you're using a discrete date part. So I hope that this is some of the things that you in this video that you are now well assured of, organized your thoughts, organized the kind of different points that differentiates or makes a difference between the continuous and the discrete data field. Okay, all right, this is the end of this video. I'll see you in the next video where I'm going to talk a little bit more about interesting things around date and how we can change the calendar of or the order of days or of weekdays in our visualization. See you in the next video.